Hello, I'm Min Hong, group leader of Group 6, and I'm hereby to present you our proposal of the integrated design project. And we'll be doing mushroom farming along with Group 9 and 13, and we are honored to given the task to power the system, which we name as power monitoring and supply system. And the main goal of this Sulam project was to reduce the operation cost of the Sulam. And after we do some research on the mushroom farming, it can be divided into three major process, and we found out it is unrealistic to do the sterilization process, which is the most important one, to prevent the mushroom being outcompeted by other species. And we were mostly focused and our system we're mostly focusing on the fruiting process only, and the criteria of mushroom farming was humidity, carbon dioxide, and temperature. This is the general overview of how of the project of our project of our farming system, which is divided into four systems: power supply system, watering system, ventilation system, and more monitoring system. And this is the ideal design of our subsystem. And we adapting the industrial revolution 4.0. We'll be using sensor along with IoT to help us monitor our system without being on the field. And the design was followed the criteria of the sustainable development goal, which is as below. Which we, we, we follow three of the SDG, which is SDG 7, affordable and clean energy, SDG 11, sustainable cities and communities, responsible and SDG 12, responsible consumption and production. And the design will be follow the criteria of this SDG, as the power generated must be clean and will not pollute the environment. So we will not release any toxic gases towards the air. And it will be renewable and sustainable energy source, which will not use fossil fuel and our system must be resource efficient, with which we does not waste extra electricity or water.
Assalamualaikum and salam sejahtera. My name is Arif Hakim Rizal. My meeting number 211110710. I'm from Group 6. Today I will present about site visit to Mahatafi Science Darul Mutakin or Masdar. Our group has been informed to do our project on the red square area as shown in the picture on this slide. After visited this area, we have found that there are no power source in this area and insufficient of water flow that can be used to install a hydro-powered turbine as our power source. But after we observe all areas in these sites, we found there are some open area in this site. So with this some open area, we can install our solar panel to this area. After that, we can use a solar energy as our power source. Another that there are water piping system in this area. With this piping system, we can use it as a water source for us to watering the mushroom farming to keep the mushroom to get enough humidity to keep grow up. That's all for me. I pass this slide to Lim Chun Hong. Thank you.
Hello, it's me again, and I'm will be continue the problem statement. So after the research and the site visit, we found out we have three major problem faced in this project, which is the dilemma on the automated mushroom farming would higher the electrical costs, since all the automated mushroom farming will use electronics such as sensor, water sprayer, and also fans. These things require electricity to work, so it would higher the cost, the electrical bill. And the second problem faced by us was the farming system will not be function if there is absence of power source. So when there is a power outage, the which the system loses its power source, all of the water spraying system, the temperature maintaining system, or the fan will not be working. So under this condition, the mushroom might die. So the last problem faced by in this project was the water use in the farming process is also considered as operation cost. Continuously watering the large amount of mushroom require a lot of water. So if we are using the waters from the water pipe, will also be a cost in a large amount of users. So thank you very much.
Hi, I am Felician. Our group has outlined a few objectives of the project based on the problem stated. The first one is to develop a sustainable power monitoring system to track the power flow. The second one is to establish a real-time monitoring features to provide real-time data. The third one is to assess the effectiveness of the monitoring system. The fourth one is to create a water supply system that is effective and sustainable. The fifth one is to implement a water recycling and conservation measures to minimize wastage. And the sixth one, to establish a reliable backup water supply system that ensure continuity of water supply during shortage period. Next, to achieve all the objectives, the scope of the projects are divided into two main scopes, where each scope has a few deliverables. The first scope is to study the possible sustainable power source that can be used to generate sufficient power for the mushroom farming system. And the second scope is to install an integrated water system that can supply sufficient water to the mushroom farming efficiently. Next, our group has agreed to go for solar energy power system as our power source as it has been implemented widely in the agricultural activities due to its high sustainability and high cost efficiency. According to the research by Oran Chio-chan in the year 2017, the power usage of a small-scale mushroom farming system is only around 225 watts per day. This means that a 300-watt solar panel kit is enough to power up the whole small-scale mushroom farming system. How does a solar energy power system work? The solar PV panel captures the sunlight and converted the photons into electrons, and the electrons produce that current, and the current is supplied to the whole farming system. In this solar energy power system, there are a few components, and the first one is the solar panel, which is used to convert the sunlight into electricity. There are a few types of solar panel. There is monocrystalline, thin film, solar cells, and polycrystalline. As we can see in the table in the slide, polycrystalline solar cell is the best option to go with due to its lower price but relatively high efficiency. Next is the battery for energy storage, which is used to store collected solar energy. There are two types of batteries, that is lead acid batteries and lithium ion battery. As we can see, we can go for the lead acid battery as our battery option due to its low cost, as our project is on a budget constraint. Next is the charge controller, which is used to control the flow of electricity to prevent overcharge. The price range is between 11 ringgit to 50 ringgit, with the price varied due to capacity and or additional features. The last component is the inverter, which is used to convert the direct current into alternating current. The price for an inverter range between 36 ringgit to 78 ringgit, with the price varied according to the power capacity of the inverter.
I am Parandama Karupia and I'll be presenting our market survey analysis. This is our respondent demographic, which mainly consists of four age group of people. We choose this age of group of people is because to capture a broad range of opinion and insight from the younger generation who are more tech savvy individuals, and also to the generation who are more experienced and knowledgeable. The following questions were designed to obtain the respondent preferences. Starting from question number 1, we asked whether they would prefer a fully automated mushroom farming. More than half of the respondents agreed and strongly agreed with the rest of them. In the second question, we asked whether they would be willing to pay more for an automated farming system, and over 80% of respondents disagreed. So, in the third question, we propose a hypothetical solution for the high cost, which is we provide a solar power as an energy source. So, with this, more than 70% respondent agreed with this solution. So, all the three questions from the previous slide, everything translates into one customer requirement, which is to save on electricity costs. To fulfill this requirement, the engineering characteristic that plays a crucial role is electric consumption. One possible solution to use energy harvesting systems such as solar panel. Looking at the next question survey result, more than 70% of the respondents prefer a 10-hour long rechargeable battery that can last without charging the solar panel. It is clear that the customer requirement here is a reliable and durable battery. Converting this into an engineering characteristic, we want a high capacity battery to store more energy and a high life cycle battery that can be used multiple times without a capacity loss. On average, most respondents agree to implement a monitoring mechanism. So the customer requirement here is to able to monitor the capacity of battery and the power usage of the system. The engineering characteristic required are high accuracy and high visibility battery monitor which are user friendly, as well as an high accuracy energy metering mechanism to ensure an accurate reading on the monitor. So that includes our market survey analysis. Thank you.
Name ni Nabili Imran Mizani. My meter number 211110760. I will talk about the house of quality, what we call the HOQ. HOQ have the three sections. One section for technical requirement, one section for competitive benchmark data, and one section for customer requirement. Why the technical requirement part describe the specific features or engineering parameter? That's why the match the customer requirement. Customer requirement section capture for the voice of the client. The metric configuration relation weight and goal for the allocate in HOQ. Step for deliver HOQ. First step the customer requirement. Second step the technical measure. Growth correlation metric. Relationship metric. Important rating. And lastly the competitive evaluation. The industry relationship between engineering features and the customer requirement is shown by the yellow zone. 9 is the strong, 3 is the medium, and the 1 is so very weak. On the other hand, engineering requirement rank is the red color row according to the client need, the which indicated the relatively significant. The important rating result of the calculating the sum of the column the multiplied by the customer important factor, which the derived the market survey will be presented by the green zone. The second point, primarily product design specification PDS. Product verification, the prototype portable solar cell system and utility energy source the smart mushroom farm. The system status, the solar cell sekarang charging for the solar panel to the battery and the loading for the battery to ignition system. Designed to be open, simple, lightweight and easy to important. Market identification, the target market for the Mazda. Initial launch, the Mazda only. Maybe initial product have the one, competitive product produced involve the Wi-Fi monitor and current product not just have the smart solar energy monitor system. Physical describe material to be described. Weight based on the material target less than 4 kilogram. Measure to be described. Rectangular size. Number of the compartment have the two is the hardware and software. Financial requirement The policy over like the circle involve the range budget and competitive the project. Guarantee I will be give 2 year